Okay, so we saw on the top, we got kind of an introduction to rates of change here, and rates of change are going to be like just applications of our first principles stuff, right? So just finding slopes of tangents and secants and whatnot, right? So you're going to find as we go through calculus that we're more interested in the instantaneous rates of change as opposed to average velocities or average speeds or anything like that, right? So we're, in other words, we're interested more in the tangents relative to the secants, okay? And so we'll just jump through the second question here. A dragster races down a 400-meter strip in 8 seconds, okay? Its distance in meters from the starting line after t seconds is represented by that function, okay? S like a function of time, position as a function of time is equal to 6 t squared plus 2t. Okay, we want to find its average velocity over the first 4 seconds. Okay, so we want to find ultimately what the velocity or average velocity would be between t equals 0 and t equals 4. Okay, and so we can just say, all right, well, the v average is going to equal the value of the s function when I plug in 0 and 4, right? So we're going to do final minus initial. So the final is going to be after 4 seconds minus the position or the position after 0 seconds, right? Which is obviously 0. And then divide that by 4 minus 1, the two x values. Okay, and we're going to see that when I plug that in, we're going to get 104 minus 0 over 3. So we get an average velocity of 26 meters per second over that time interval. Okay, now if I'm interested in the velocity as it finishes the finish line, right? As it crosses the finish line, right? It's going to take 8 seconds to get there. Okay, now if I'm interested in one specific time, like let's say 8 seconds, I'm interested in the instantaneous velocity, which we know as being the um, slope of the tangent at that particular time, right? 8 seconds. So I have a position relative to time graph, but we can find, we know that the slope of the tangent of this would represent the velocity or speed at that particular, whatever particular time that we're interested in, right? The slope of the tangent, which is where some of you may have seen this, but this is well, in physics, we would have had like a position time graph, much like what we had up here, right? And anywhere we found the slope, you will remember from grade 12 physics or 11 physics, if you've taken that, if we find the slope of a position time graph, we get the speed or the velocity at that particular time. So how do we denote that? Well, turns out, using our calculus terms, if we were to find s prime of t, that's going to represent the slope of the function, right? mt. Where are we interested? We're interested in, well, let's do it generally, okay, and we'll see what shakes out, okay. So I'm interested in s prime of t. Well, we know what s prime of t is equal to. That's equal to the limit as h approaches 0 of s t plus h minus s of t, the original function, divided by h. Okay, so let's plug some stuff in there. T plus h, we're gonna write that out. So s prime of t is going to equal the limit as h approaches 0. Let's figure this out. We're going to take the function. Everywhere I see a t, I'm going to replace it with a t plus h, okay? So we're going to say 6 t plus h squared plus 2 t plus h. And then I need to minus off 6t squared plus 2t. And then all needs to be divided by h. So let's just do some simplification now, collecting like terms and whatnot. It's the limit of h approaches 0. We're going to get to 6t squared plus 2th plus h squared plus 2t plus 2h. And then distribute the minus into both things. You're going to get minus 6t squared minus 2t, all divided by, sorry, I'm just missing one thing here, bracket, h. Okay, so now distribute the 6 in, and then we should be good to go. Limit of h goes to 0. We're going to see 6t squared plus 12th plus 6h squared plus 2t plus 2h minus 6t squared minus 2t, all divided by h. Now, let's have a look. 6t squared will create a 0p with 0 pair with minus 6t. We're going to have 2t with the minus 2t there, and that might be it. Okay, as it looks. Okay, so now we'll just rewrite this and clean it up. S prime of t is equal to the limit as h approaches 0. We're going to have 6h squared plus 12th plus 2h. Okay, and we can factor out an h, and we're left with 6h, not h squared, just 6h, plus 12t plus 2 divided by h. Right? And now we can actually evaluate this limit. We can see what happens when I evaluate by plugging h equals 0 in. We're going to see that we're going to be left with 12t plus 2. This represents the velocity anywhere along that curve. Where is it that we're interested in? Well, we just want to check what the speed might be when t equals 8. Right? So 12 times 8 plus 2. Right? Well, that's going to be 98. So there you go. I think this is kind of cool because we're actually taking the math that we've learned and applying it to a situation where, like we can figure out something, right? So it crosses the finish line at 98 meters per second. Now, the last part here is we want to determine when its velocity. We want to find when its velocity is 38 meters per second. Well, that's fine too, right? Because we now know. What's this telling me? Part C is telling me that S prime of t is equal to 38, right? So I can just replace S prime of t. So we know that 38 is equal to 12t plus 2. And we just want to solve for what the time was when the speed was 38 meters per second, right? So we can say, okay, well, 38 minus 2 is equal to 12t. 36 is equal to 12t, so t is going to equal 3. So this is, it's at 3 seconds. When t equals 3. 38 meters per second, sorry, when t equals 3. Okay. I have one more for you guys to do here, and then that'll be it for today. And then you guys can have a go at the homework questions, okay? So you can see I want to spend as much time as I can, given the circumstances, on doing this for the first principles, right? Because you guys can see how it comes up it just keeps coming up. So I always want to give you guys the appropriate amount of time to actually thoroughly understand this stuff. I found I didn't really start too far ahead of you, right? In terms of, like, I've obviously done this course before, but it's been such a long time since I've had to do first principles, for instance, that I'm almost starting at the same point you are. And I've gone through all your homework questions now. Like I have a pretty good handle at doing this, right? There is still some harder questions, but that's where the challenge lies, right? But I don't have, and hopefully you won't either, as much of an issue working with a question with a simple equation like this using first principles. Okay.